Hi. What I'm going to do is go through a little example because I only have 20 minutes without explaining anything because there's only 20 minutes. And I'm going to use two different tools, DTrace and MDB. And I'm going to do this. Okay, so if you wanted to follow along, and I'm sure you all do, you could download SmartOS because DTrace and MDB run on SmartOS. They don't run on Linux. Or you could go to Joint and provision a machine, or you could set up an account on Manta. So you could take your app, which you're running on Linux or on Windows, and you're having problems with it, and you can basically copy the app to Manta, spin up a machine on Manta, do your debugging, your performance analysis or whatever, and then once you're finished, you spin down, and if you were following along and doing what I'm doing in this little session, total cost would be about, I'm going to guess about 5 cents, because I'm going to try to finish in 20 minutes. So the problem I'm going to look at is a memory leak. So I start up the startup node on some application that happens to be named Leak 2, and one of the things I can see, I want to see, okay, the memory leak, and if you notice here, there's a column called size, and size is basically the virtual size of node that's running, and you'll notice that that is growing. So when you run this, what will happen is it will show the first line, and then 5 seconds later, show again, and then 5 seconds later, etc. And you can see it's growing. No, I don't want to sit here and explain all the fields in PR stat, but this is basically the same thing you would see, or very similar information you can get out of top. So it's growing. This actually is growing fairly quickly. Yeah, roughly a meg every 5 seconds, which, by the way, most of the time when you're solving memory leaks, they will never be solved in 20 minutes. Okay, just in case you thought, oh, this stuff is easy after that. Okay, no, it's never this easy. Okay, so one of the things I'm going to do is take a couple dumps. I'm sure you all did this morning, but each dump. So I'm running an application called gcore, and gcore basically takes a snapshot of the running application and saves a core file, which it names with the process ID of the process that you dump core to. So the reason I'm doing this is I'm going to basically take the dump, wait a little bit, take another dump, maybe wait a little bit, take another dump. Which, if you've been drinking whiskey all night, you're probably doing that already. And once I've taken these dumps, I'm going to go and look through the dumps. I spent a lot of time looking at dumps, and it's interesting to have, talking with someone in the company on chat and saying, Max, I need to look at your dumps. Okay, so anyway, you take the dumps, and what you want to do in these dumps is you want to look for things that are growing. So how do you... All right. Okay. All right, so here I am. I'm looking at the first dump with a tool called MDB. Now, some of you are looking at MDB and going, shit, I thought DTrace was... that's completely foreign, and what the hell syntax is this? Don't worry about it. Just do what I'm showing here, and if you start using MDB, you'll end up either running away in horror, or you'll get to really like it. I've been using it. It's been around longer than DTrace. I've been using it a long time. It works really well if you know what you're doing, and if you don't, it takes a lot of practice. So I'm loading a module into MDB that is basically aware of V8. So this is basically a library, v8.so, that MDB can use. And then I'm going to run this command, find JS objects. And find JS objects is going to show me, it basically makes multiple scans through the dump looking for objects. And I'm showing just a little bit of the output, which happens to be at the end. And the thing I want to note here is there's the second column in this output. The first column is an address, and the second column is the number of objects of a particular type. Third column has a number of properties, and then there's some information about the object, what the object is. And I take this last guy, and the reason I'm looking at the last guy is that I'm not sure what to look at. But in fact, the next dump, what we're going to see, I'll go to it for a second, in the second dump, that last guy, instead of being 4,000 something objects, it's up at 8,000. So this is growing. So what you'll find here is that when you do the find.js objects, it'll show you all the objects, including objects that are no longer active, but the garbage collector hasn't come along. So you'll see some of these objects, the size, the number of objects will grow and shrink depending on when garbage collection runs. But this particular one, what I saw is it doesn't shrink. It steadily grows. So this makes me think, is this a problem? And yeah, so I'm taking the address in both cases and dumping out what the object is, and here I see this hello leaky world, which I recognize because it's part of my code. All right. You can actually look at every single object. No, I'm not going to do that. I did this on Monday, and if you're around this afternoon and you're interested, we'll be doing more of this stuff and Manta, but you can find all kinds of information in the dumps. People's names are in the dumps. Isaac, you're in every node dump I've looked at. What you're doing there, I don't know, but you also find other people's names, like customer names and telephone numbers and other stuff that you don't want to let any just random person look at your dump, because who knows what kind of shit you're going to find there. So I dump this out and I go, okay, I see these things, and actually one of the things I did, which I don't show here, is I grepped for a leaky world, and I see it the first dump a couple hundred times, and the second dump several hundred more times. So it's obviously something that's growing in the application. So what's the next step? Well, I have to think about this, a memory leak. So you guys do a lot of node programming, and you're thinking, okay, memory leak, look for a place where you're not handling closure properly. And I'm more of an OS guy, so I'm thinking, well, how do you actually allocate memory? And the way you allocate memory is you either put the memory on the heap, and this is through some system calls, same system calls on Linux, by the way, break or sbreak, or you grow the heap, or you grow the space by using another system call called the mmap. And first thing, so I'm not sure which way this is going. Is it growing the heap, or is it doing something else to take up more space, to grab space? And by the way, before we go any further, everyone knows the problem with memory leaks, right? You get these huge dumps. No, the problem with the memory leak is that generally, over time, they can cause your application to run slower, they can cause your system to run slower, and generally, eventually, the application will crash. Okay, I just can't do anymore. So here, I'm running a command called pmap, and yes, this is on Linux. And pmap is showing me, well, for heap right now, I've got basically about 3.5 meg for heap. The total size of the address space down at the bottom there is 374 meg. So these values are in kilobytes. And that's the running process. So now what I might do is wait a little bit and run this again, and you'll notice that the heap size hasn't changed. So for me, I know, okay, this is not break, this is not sbreak. Heap isn't changing. But the total size went from, what was it, 374 meg to 380 meg. So the total size is growing. So I'm thinking, okay, most likely we're m-mapping to allocate more space, to grab more space. So So how can I look at this? How can I find out where it's mapping? Well, of course, you guys did see my t-shirt, right? Is this being recorded? DTrace, of course. Or as the person last night to me said after, I think, a lot of scotch, DTrace, right? You're great, whoever you are. But probably he's not here right now. Okay, so the heap isn't growing. Node is probably using mmap, and it's probably using an mmap call that looks like this. And yes, if I look through V8, I can find this. And no, I didn't bother because I know how this stuff works, and this is the only way it can do more allocation. So I write a little DTrace script. So now is when I spend the next 10 minutes teaching you everything about forget it. I teach a DTrace course. I plug things. In other words, I plug DTrace course. I'm working on a course on node debugging and performance analysis. So if you want a lot more information, take the courses. So this little DTrace script is going to watch mmap calls that are being made by a particular process. In this case, the process I'm going to be looking at, the PID, is going to be the PID for leak 2 for that node process. And whenever I get an mmap call, I'm going to print out how much memory I'm allocating. I'm printing out which mmap call it is, because there's mmap 64, which handles large files. And what's the other thing? And I'm printing out the number of bytes that I'm allocating and which file descriptor. And the other thing I'm doing, probably much more importantly, I'm using something called JStack. And what JStack is going to give me is it's going to give me a stack trace where the mmap was called from. And the reason I want to see this stack trace become obvious on the next page is that the stack trace will tell me where to look. There it is. The function run at leak2.js at line 13. And what else is here? This stack trace, by the way, I'm really condensing this. I got rid of a lot of stuff, but you look for your stuff, because of course, if there's a memory leak, the problem is in your application, because the V8 engine and Node itself do not have any bugs. Right, Isaac? Is that correct? Pretty much. Except for the bugs that are there, but Isaac takes care of these, or whoever else is working on core. Here is the League 2 program, and no, I'm not going to go through this. You can go and look at, you can go download it if you want. It's on GitHub. And there's line 13. It actually also tells me about line 27, which is actually at the end of the file. So it's a closure that isn't being handled properly. And that's it. Thank you very much.